Hey guys, it's Mr. Sarley. Welcome to your YouTube homework review. This week's packet is going to focus on decimal multiplication. And all of these problems are kind of best done without a calculator because they're super easy with a calculator. But in general, we're practicing for book 1 of the state test when you don't have one and you just have to know how to do problems like this. So this very first problem says 2/10 times 3, and I'm just going to line this up. It's 2/10 times 3. When you're multiplying, you really don't need to line up the decimals at all. You kind of deal with the decimal at the very end of the problem. So in this problem, 3 times 2 is 6, 3 times 0 is 0, so I'm not even going to put it. And then at the end of the problem, you take a look and you see we have one number that's after a decimal. And so we start over here and we move it right here, and we end up with an answer of 6/10. But it's also good just to make sense of this problem. And really what it's telling us is we're going to do 2/10 plus 2/10 plus 2/10, just 3 times. And that's just going to be the same as 6/10. Finally, just to show it to you this way, some students really like fractions more than decimals. So something you could do when you see a problem like this is you can rewrite 2/10 as a decimal. And then once you have that, it's 2/10 times 3, which equals 6/10. And notice that that's equivalent to our answer. Okay, I'm going to mostly solve these problems as decimals though. So for B, we have 3 times 12 and 5/10. So I'm actually going to start with the number that has more digits on top, and then again multiply it by 3. And again, you don't have to line up the decimals when you're multiplying. 3 times 5 is 15, so we got a 5 here. I bring up the 1. 3 times 2 is 6, plus this 1 is 7. 3 times 1 is 3, and then since we have one number after the decimal point, I'm just going to move that right over here, and you get an answer of 37 and 5/10. Alright, so for C, you could definitely line it up like this and multiply it out to find your answer. I just know that 5 times 6 is 30, but then since we have one number after the decimal point, you need to bring it over, and you get 3.0. And again, over here, it would look like that same process, 3.0. For D, we have 5/10 times 4/10. And so when I line this up, I have 4 times 5 is 20. And I guess you could write it like this if you wanted it to. Then 4 times 0 is 0. Bring down the 2. Sorry for that decimal. That's a little confusing. But now check this out. This changes it a little bit. We have not just one number after a decimal place, but we have 2. So what that means is we actually have to move our place value over 2 spots, and we end up with 20 hundredths. And you can kind of see why this happens if you rewrite these in fraction form. 5/10 times 4/10. When you do that, you get 20, but notice the denominator is going to change because 10 times 10 is 100. And that's why we have 20 hundredths as our answer. I think I'm about to get kicked out of the auditorium because it is detention time, but maybe I'll get lucky, and you guys will get lucky you don't have detention today. But moving on to the silver level, we have 3.5 times -2. So the same rules that work with integers work with decimals with negatives. Since the factors have different signs, I know my product is going to be negative. But let me just line things up. I got 3.5 times, I'm just going to ignore the negative sign for now. 5 times 2 is 10. 2 times 3 is 6. Bring down the 1, we're at 7. And then I just bring over the decimal place so it's right here. And then, since the signs are different, my answer is going to be negative 7.0, which is just the same as negative 7. For F, again, the signs are different, so I know my answer is going to be negative. I'm going to start off with 4.15, because that has more digits. And then I'm going to multiply 2, remembering that I don't have to line up the decimal when you're multiplying. 2 times 5 is 10. Bring up the 1. 2 times 1 is 2, plus 1 is 3. And 2 times 4 is 8. Then, to figure out where the decimal goes, let's see that we have 2 numbers after a decimal place, so I move over 1, 2, and I get 8.30, but again, the signs are different, so I know that this is going to be negative. For G, since the signs are the same, I know my answer this time is going to be positive. I'm going to start off with 2.5, almost thinking of it as like a 25, times 6. 6 times 5 is 30. 6 times 2 is 12. 13, 14, 15. And then we have one number after the decimal place, so I'm going to come over 1. And I end up with 15.0, and again, the signs are the same, so I know that my answer is going to stay positive, positive 15. For H, the signs are different, so I know my answer is going to be negative. I have 5 times 2 tenths. 5 times 2 is 10. 5 times 0 is 0. Bring down the 1. And then we have one number after the decimal place, so it's going to be 1.0 or a whole, and the signs are different, so I know it's negative. I see that, and I know it's correct because it's basically just like 5 times 2 tenths. 5 times 2 tenths would be 10 tenths, and 10 tenths is the same as a whole. Alright, so these questions were taken from state test questions. Basically, they're in book 1, so you don't have a calculator for this, and it's good to practice it out. For this one, 15 times 6.2, it helps to know 2-digit times 2-digit multiplication, so this might be a review for some of you. Starting off with the 2. 2 times 5 is 10, so I bring the 0 down here and bring up the 1. 2 times 1 is 2, plus 1 is 3. But then, I'm going to start by doing 6 times 5. That's sort of like next. Now I'm going to focus on this number. But first, you have to add a 0 to the first place value. Now we do 6 times 5 is 30. So I bring down the 0 and bring up the 3. 6 times 1 is 6. 7, 8, 9. And now I'm going to add up those two products. And then I just need to make sure the decimal place is moved over 1 because we have one digit after a decimal. And this answer would be 93. A more advanced way of doing this problem, and why I know my answer is right. Sorry, now there's a detention going on, but 15 times 6 is 90. So I know my answer should be around 90. But then, using the distributive property, 15 times 0.2, that ends up being 3, or 3.0. And add that together. It's like a more advanced way to see that the answer is 93. Alright, so 6 times $3.45 is how I'm thinking about it. Imagine you're buying 6, let's say sandwiches. Chopped cheese is about $3.45. We want to figure out the total cost. So we're going to do 3 45/100 times 6. And then we just need to multiply this out. 6 times 5 is 30. 6 times 4 is 24. 25, 26, 27. 6 times 3 is 18, 19, 20. I got two numbers after the decimal place, so I'm going to get an answer of 20 and 70 hundredths. Again, a more advanced way, because I kind of hate this algorithm, would be I could do 6 times 3, which equals 18. I could do 6 times 4 tenths, which equals 2 and 4 tenths. And I could do 6 times 5 hundredths, which equals 30 hundredths. And if you add those three products together, it's another way to get our answer. Alright, last one is 25 hundredths times 10. The cool thing about this one is you can think about it as quarters. Like we have 10 quarters. How much would 10 quarters be? And you could definitely, if you wanted to, you could definitely do it this way. But it's just kind of obnoxious to do it that way. So I know a couple of things. I know that 4 quarters is $1. And that means that 8 quarters is $2. And so if I just added 2 more quarters to that, I know that my answer would be $2.50. And the very cool thing that I think Stephen A. pointed out in one of the lessons this week was when you multiply by 10, a decimal multiply by 10, something really interesting happens with the decimal point. All you really need to do is take it and move it over one place value. So instead of 0.25, you get 2.5. I love stuff like that because it's a way to do math in your head. So we're going to go